Today we're going to be talking about SOHCAHTOA. So you might recall this from your geometry class. SOHCAHTOA is really important, and it's the foundation of what we're going to do today. So in short, I'm going to write it out. Sine theta is O over H. Cosine theta is A over H. And tan theta is O over A. And O is referring to opposite. A is referring to adjacent. And H is referring to hypotenuse. And this is the most important part. All of these terms, they only apply to right triangles. So everything we do today is going to apply to right triangles. So let's try our first one. So let's find the value of each of the 6 trig functions of the angle theta. So notice how there are 6. Let's not worry about that for now. Let's just do the 3 we know. If you look at our picture here, this theta is given right here. That'll always be the case for these problems. So what I want you to do is draw a stick figure right here. That's going to be your perspective. So 5 is clearly the hypotenuse, it's the longest side. 3 is your adjacent because that's next to your stick figure, which means this must be your opposite. Now you could do the Pythagorean theorem, but hopefully all of you know that's a 3, 4, 5 triangle. Now we're going to start doing some trig. So what I want you to do is write the 3 functions in this exact order. Sine, cosine, tan. And now look at your triangle. Sine is O over H, so O over H. So you're going to write 4 over 5. Cosine is A over H, so you're going to write 3 over 5. Tangent is O over A, so you're going to write 4 over 3. And now look how easy that was. Now notice how that's only 3 functions. We need 6. So the other 3 you're going to learn today, let's go back to the top here. These are called the reciprocal identities. The first one is cosecant. So you're going to write CSC. That is the reciprocal of sine. And again, that's pronounced cosecant. The next one is secant, and you write SEC. That is the reciprocal of cosine, and that is pronounced secant. And the last one is cotangent. That's just cot. That's going to be 1 over tangent, or tan. And again, that's pronounced cotangent. That is something you must study and memorize. You got to have those 6 functions pretty fluent. Now I want you to write it in this exact order. Cosecant, secant, cotangent. As you're doing these problems, I really want you to focus on writing it in this exact order. Notice how all the pairs are lined up horizontally. This will just help you memorize it faster. And also for your work, look how easy it is. You just flip them. 5 over 4, 5 over 3, 3 over 4. Now we're done. Next example. Given cosine theta is 2 root 5 over 5, find each of the 4 remaining trig functions. So hopefully you can realize what's wrong with this question. I put this intentionally. Let's cross out that 4. There are actually 5 remaining trig functions. And to do this, what we're going to do is draw a triangle. So do the exact same kind of process as last time. We're going to put theta here. There's your stick figure. Here's your O, A, and H. Now it is important to know that your theta could be on the other side too, like theta could be here. And if that happens, that just changes your letters. That would make this O A is there, and H is there. So notice how H should always be the same one, but O and A can switch depending on where your stick figure is. But for this problem, it won't matter which one we choose. I'll just do the one we drew first. To start, I'm just going to write out sine, cosine, tan, and cosecant, secant, and cotangent. And fill in what we know. This is 2 root 5 over 5. Now, all we got to do is work backwards. If we know cosine is A over H, let's just fill that in. A must be 2 root 5, H must be 5. And now we can figure out that last leg. So if you want, call it x, Pythagorean theorem, 2 root 5 squared plus x squared is equal to 5 squared. 2 root 5 squared is 20. 5 squared is 25. So x squared must be 5, which means x is the root of 5. So here's root 5. And now we can figure everything out. Let's do sine, that's O over H, that is root 5 over 5. Tangent is O over A. That one would be root 5 over 2 root 5. Notice how this just reduces out to 1 over 2. And now we flip it. 5 over root 5, 5 over 2 root 5, and 2. Now in trigonometry, these answers are not going to be acceptable. We're going to have to rationalize that. So we're going to multiply by the radical on the bottom, root 5 over root 5, and our answer is going to become root 5. This one, we're going to multiply by, again, root 5 over root 5, and this will become root 5 over 2, and 2 is good. So now we'll just circle all our answers. Okay, so that's part 1. What I want you to do now is work on the problems below, check your answers, and then we will resume right here. So now that you've finished the first part of the worksheet, we can go to the next part of the worksheet. In this part, we're going to be talking about more identities. So we just talked about the reciprocal identities. That would be cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tan. And we're going to introduce a few new ones. The first one's going to be the quotient identities. Some of you may have noticed this as you're working, that tangent is actually sine over cosine. And that proof is pretty cool. Sine is simply O over H, and cosine is A over H. So notice how the H's just cancel and you get O over A, and that is tangent. So that's a pretty easy one to prove. And we just flip it to say cotangent should be cosine over sine. Okay, so that's all we need for now. Let's go to example A here. It says find the exact value. So tan 20, we clearly can't evaluate that. So we got to figure out what this thing is. And we just talked about it. Sine over cosine is tan. So you can rewrite this piece right here as tan 20. And look at that. You have tan 20 minus tan 20. That is 0. Now this next one looks pretty weird. And in order to do that, I got to teach you an identity. The next big identity we're going to talk about is called the Pythagorean identity. So Pythagorean. Unfortunately, I can't prove it to you right now. You have to learn more trig. This book just has you practice with it because it's so important in trigonometry. The identity is right here. Sine squared plus cosine squared equals 1. And the key is going to be these thetas must match. As long as these match and they're squared, whenever you add them, they equal 1 every time. And again, later in the class, I can prove it to you. Today, we're practicing using it. So for B, notice how it's not exactly like the identity. We have this piece right here we got to fix. But luckily, we know what the relationship is between secant and cosine. They're reciprocals, so that is just cosine squared, pi over 12. And now, look at that. These things match. They're both squared. It must be 1. Done. Okay, next part. Using the complementary angle theorem. So this one, a lot of people refer to them as co-functions. And I'll use that as well because I think it's easier to remember. So the theorem I'm just going to show you right below it. The theorem is quite simple. It's just sine of 90 minus theta is equal to cosine secant of 90 minus theta is equal to cosecant theta, and tangent of 90 minus theta, that's equal to cotangent. So that's the cofunction theorem, and I'll just box that for you. And again, these are going to be super helpful for today, cofunctions. It's just a theorem that allows you to change a function to another function, its corresponding cofunction. So look at sine right here. We can use this one. We can change it to a cosine by taking the complement of the angle. So just write cosine and just do 90 minus 62. That's all that theorem is saying. So sine 62 is actually equal to cosine 28. And again, all you're doing is taking the complement. And we can use that for all of them. The next one, tan. The cofunction for tan is cotan. And instead of 90, we're going to use pi over 2 because we're in radians. So just do pi over 2 minus pi over 12. That is 5 pi over 12. Next part, cosine. We change that to sine. Do pi over 2 minus pi over 4. And that is equal to pi over 4. Now for this last one, we just change that to secant. Pi over 2 minus pi over 6. And that becomes secant of pi over 3. Now to prove this, again, this is a very helpful theorem, but it's obviously easy to use, but we need to understand like where it's coming from. So really simply, let's draw your triangle here. You'll see this a lot in SAT math. All you have to know is that if this is theta, 90 minus theta is just the other leg or the other angle in the triangle. This is 90 minus theta, this piece right here. So all it's saying is that if this is A, B, and C, notice how if I have my stick figure right there, sine theta is B over C, or opposite over hypotenuse. And if I change my perspective, if I were to make another stick figure over here at 90 minus theta, I could say, well, cosine of 90 minus theta, that's equal to B over C. Therefore, these two things must be equal. Sine theta must be cosine of 90 minus theta. That's a very simple way to prove it. And again, all you're doing is kind of moving your stick figure around in your same triangle. So now we're going to use the theorem to help us evaluate some identities. And these, a lot of people have a hard time with. So I will do a couple with you. For this first one, what I want you to really understand is this. You must make the angles equal. When you get stuck on these questions, you always have to ask yourself that. Do all the angles equal the same number? So for this one, letter A, do they equal? No. So pick one of them. I'll just pick this one. We're going to change that using a co-function. So the co-function of secant is cosecant. So that's going to be cosecant 90 minus 28 minus cosecant 62. That's just cosecant 62 minus cosecant 62. 0. Done. So do the angles match? Again, no. So we'll pick one of them. I'll just pick the top one. Doesn't really matter. I'll make that into cosine. Take the complement, 90 minus 35, all divided by cosine of 55. That's cosine 55 over cosine 55, which is 1. And that's how you do those questions. So to summarize, I'm going to give you a little picture that lots of trig students have been using in my classes. Sine, tan, secant, cosine, cotan, cosecant. If I line these up with the black line, that's your co-function. If I go across with the red line like that, the red line is showing the reciprocal relationship. Those are two things that are confusing, but you have to be able to consolidate them and separate them in your mind. Okay, I'm going to do 2 of these with you just to make sure. So for 32, notice how the angles match, so you're good. And that is your Pythagorean identity, so just write 1. For 34, the angles match, so you're good. Think about what is secant 80. That's 1 over cosine 80 times cosine 80. That's 1. Okay, so work on the rest of the problems, and I'll see you in class.